Welcome back, guys. This is the last video on correlation. Some cautions related to interpretation and some applications, so why we would use correlation beyond just to see whether or not two variables were related, right? What are some very specific applications that we could use, particularly in psychology? So let's see an example here, right? We've got our number of absences and exam grades. We have what seems to be a reasonable correlation. We calculated this in the last video. We saw it to be negative 0.85. But let's look at another set of data here. So I want to address an issue of what's called restriction of range. So let's say I was looking at data on how many hours you studied on average for a final exam or across a semester or whatever. And I got your age. And I wanted to correlate that to see whether or not there was any relationship between the number of hours studied and your particular age. Two different age groups tend to study at different rates. Well, if I collect the data like this, right? So I've got, let's see, looks like 10 individuals here. If I were to run the correlation on these particular data, so we have the XY data and you can run them separately, you get a correlation of about 0.05. So remember, correlations run from -1 to +1, whether they're perfect negative correlations, perfect positive correlations, or if they're really close to zero, they're zero. There's no relationship here. So these data pretty much look like there's no relationship, right? The line of best fit would be pretty damn close to flat. But you might also notice here that I'm trying to interpret whether or not there's a relationship between number of hours studied and age, and I really only have individuals aged 22, 23, 24, and one 25-year-old. Sorry, I don't even have any 24-year-olds. I have data that only fit within a very small range of that larger age scale. Right, age ranges from 1 to, let's just say, 99, but of course we have centenarians, and the oldest woman I think was 122, Jean Clement, still rode her bike and smoked cigarettes well into her old age. But so why don't I include people of other ages? Well, sometimes a sample will be that way. You'll go and you'll collect your data, and unfortunately, because of, say, a convenient sample or volunteer sample or just randomization, you end up with a restricted range. What can you do here, and why should you be cautious? Well, let's, for example, add a little bit more data in. So say you went back and collected some more data here, right? So I go back and I say, let's find people who are freshmen and sophomores, because 22 to 25 seems to me to be seniors to even early level grad students. So we go back and we're going to ask a whole bunch of freshmen and sophomores and try and get some of their information. So we fill in this part of the table here. Now we have a lot more data. Now if we run our correlation, in fact, remember before it was a 0.05, pretty flat. We now actually would end up with a 0.56 with these hypothetical data with a fairly strong positive correlation here that we can see. And the point is that when one of our variables is only contains data in a very narrow range of that larger scale, then that is going to bias the interpretation of that correlation, because it doesn't show how the y variable would go up or down at other positions on that x variable, right? Because of that restricted range. So you have to pay attention to this sort of thing when you're calculating your correlation and when you're interpreting your correlation coefficient. Another thing that can happen is an outlier effect. So let's see this one individual, right? So this is the number of hours studied per week, how often you're studying, correlated with monthly cell phone bill in dollars. Right, so there's an individual here who seems to be studying 20 hours a week, but also has a $500 cell phone bill. So perhaps they are playing Candy Crush while they are studying or something like that. But if we take, again, these XY data and we run our correlation, it's very sort of modest, a very small negative correlation. Right, in this case, it's a negative 0.135 or a negative 0.14. But what if I just take out this guy, right, that outlier effect? What if I get rid of him, her, I don't know who it is, take him away, rerun our correlation now with these data? Now we end up with a correlation of 0.39, right? So we went from a negative 0.14 essentially to a positive 0.39. That's a major shift, a slightly negative correlation to a moderate to almost large positive correlation, right? Our line now, a big sort of steep positive increase that shows that strong relationship. So again, think about how outliers may affect your overall correlation coefficient. Now, I've told you in this class that for data that we are using on the exam or on a homework assignment, I do not want you to eliminate outliers because we need to make sure we're all using the same data. But in your own data, right? If you are working for somebody, you are doing research, or doing anything like that, then please consider the way these things can affect your correlation coefficients. All right, so let's see some applications of correlations, how you would use them for things like testing reliability and validity. So I guess let's start by talking about what the hell reliability and validity are again, so we can refresh here. Reliability is essentially what we might consider the consistency of a measure. So you're a psychologist and you're developing a new measurement to figure out whether or not people are depressed, or to figure out whether they're shy, or to figure out whether or not they're extroverted, whatever you're interested in. So you develop a set of questions and some other behaviors you can observe or quantify, and now you want to know, is it reliable? So if you're extroverted, then you're going to be extroverted today and tomorrow, right? And the next day, and the next day, and the next day. Even if there's slight hiccups in how extroverted you might be, that's a fairly stable personality characteristic. So one thing we can do to figure out whether or not the measure I just created is worthwhile, is to perform test, retest reliability. So I get a handful of people, and I have them all fill out my measurement here of extroversion, and I record their scores, right? And so let's say it's a simple 1 to 20 scale, and if you're on 20, you're highly extroverted, and if you're a 1, you're not, so you're introverted, okay? And some of you score a 5, and some of you score a 20, a 27, and I record all of those data, and I call it the X variable, right, for time 1. Then, I'll say a week later, I bring everybody back, and I have them complete the exact same thing again. I record all of those data now as the Y variable, pairing it up. So Joe's data is still Joe's data, and a week later, and Sally and everybody else, your data all stays together from X to Y. Then I simply run a correlation coefficient, right? I run the Pearson correlation coefficient. If I find a positive correlation, it's saying that when 1 was high at time 1, you also tended to be high on that same score at time 2. If you were low in extroversion at time 1, you're still low in extroversion at time 2. That's reliability, right? Shows consistency over time. And this particular method, test, retest reliability, is probably one of the more common forms of testing reliability. And again, it just uses a simple correlation coefficient. Another way we can look at it is a more related sort of an internal reliability, what we might call split half reliability. So let's say we look at the multiple choice questions on any given statistics exam. So let's say I have 6 multiple choice questions. It's not very many, but let's just say there were 6 multiple choice questions on the entire exam. All 6 questions should be of relatively equal difficulty. There's no reason why one should be the one that everybody does bad on, and the other 5 are the ones they all do good on, assuming it's a good measurement, right? And so what I should be able to do is essentially arbitrarily group questions. So one way is to say take all the odds and all the evens. The first half of the odd numbered questions shouldn't be any harder or easier than the even numbered questions because it's all random, right? And so I take those odds, I take those evens, I find out your score on each of them, find out everybody's score on each of them, and then I correlate them. They should show fairly high correlation if those 2 sets of questions are roughly equal in difficulty or in measuring extroversion or whatever our measure happens to be. Now that's only one way of doing it, is odds and evens. You could do first half, right? So items 1, 2, 3 versus items 4, 5, 6 and see if they're correlated. You could do items 1, 2, and 5, and 3, 4, and 6, and however you wanted to group them. If you did them all those possible ones, and then you compared all those correlations and took the average of all those correlations, that's what's called coefficient alpha or Cronbach's alpha, right? It's sometimes used in really well establishing the reliability of major questionnaires and inventories, things like, say, an SAT or ACT exam, right? Making sure that all those questions are reliable and there aren't just a few that are throwing that reliability off because people don't sort of score the same over time. Some people get them right and some people don't get them right. And anyway, that's another way to use correlation to figure out a measurement of reliability. Now, why do we measure reliability? One is to detect all the random measurement errors that could occur out there, right? It's going to happen sometimes that you do have some measurement error because everything that you measure is going to be a combination of whatever it is you're trying to measure, plus all these other things that can influence it, what we might call noise, right? And so frequently we're doing it to sort of see whether or not there's some evidence of errors in measurement. If there is, then we are unlikely to show some reliability over time. So we're fixing our measures, where we're making sure they're actually measuring things in a way that provides some reliability. Now, not all measures will be reliable, right? A measurement of mood should not be reliable. I might be in a good mood today and a shitty mood tomorrow. That is somewhat fluctuating. And so retest reliability is not going to be a great way of establishing reliability for something like that. Another really good reason we measure reliability is frequently as a precursor to checking something that we might consider at least as important, if not in some cases more important, and that's basically validity. Right? Validity is, there's a few types, but essentially knowing that what you're studying is actually the thing you think you're studying. So let's take that extroversion scale. I can find reliability. Right? Let's say my extroversion scale was actually one of those shoe sizer devices. Right? And so I put it on your foot, and I measure the length of your foot, and I say, because of your size 10.5 foot, you are this level of extroversion. And I simply establish an extroversion value for each foot size. You come back the next day, I measure your foot size again, it's the exact same size. My measure is reliable. But is that measure of shoe size at all an indication of extroversion? Is that measuring extroversion? No, right? So that would be a very invalid measure. So how do we measure validity then? How do we determine whether something has validity? More frequently, it's to compare it to some criterion, to some other established external standard. So let's say, for example, I wanted to see whether or not my measure of extroversion is accurate. Well, one thing I could do maybe is to, after all 20, 25, 30 people fill out my extroversion scale, I give them a break, a sort of snack room break, where they can all go into the same room together and grab some snacks, get some Kool-Aid, sit around at tables, do whatever they want. Now, there's enough tables and chairs that they could either sit with people or without. And then I simply look and observe whether or not the extroverted people that, according to my measurement, are extroverted, also then hang out with other people. They talk more with other people. That's one way of determining criterion-related validity, right? We're establishing it with some other criterion. It could be with another measurement, right? There are other measures of extroversion. I just want to know if mine is a good one. And so I can simply correlate the measure of extroversion I get from somebody else's scale with this new one that I've created. And if they correlate fairly well, then I probably have a decent measure of extroversion. Another form of validity is what we might call, another way of establishing validity, I should say, is what we might call postdictive or predictive. Now, that still tends to be criterion related, right? We're still going to correlate it with some other behavior, but in this case, it could be something from the past. So I might have predictive validity, where my survey of extroversion predicts a later behavior, right? And so, like I said, maybe a break later on, I would see that you also were extroverted, right? Or I might go back and watch some home movies and see how you behaved in those, or something like that, in which case I'd be sort of postdictive, right? In either case, it's where that other criterion's coming from. Are we using a criterion from the past, or are we using a criterion that we see in the future, either before or after they take our new measurement that we're trying to establish validity for? Either case, we establish that, we correlate it, and we have our measure of predictive, postdictive validity, right? High correlations are best. Low correlations, low validity. We can also, instead of doing predictive, postdictive, we can have you do two things at the same time, right? We can walk and chew gum, in which case we'd be having you, say, fill out two different surveys at the exact same time that you're in the lab today. So you'd fill out my measure of extroversion, then you'd fill out another measure. Other people would do it in the opposite order, so that order didn't matter, right? We don't want order effects. But otherwise, you're doing it sort of concurrently. Big surprise, we call this concurrent validity. We also have a few other forms, so there's internal and external validity. And in fact, I've got a short little video let's watch about different types of validity to kind of sum it all up. All right?
Imagine that you wake up one morning with a cold. You're coughing and sneezing and just generally feeling icky. You think you might have a fever, but you're not sure. You get out your thermometer and stick it in your mouth. But when you take it out, the thermometer reads 72 degrees, which is the temperature in your house, not the temperature of your body. In psychology, there are many different tools used to measure traits. Surveys, observations, brain scans, saliva samples, these are just a few of the many different tools used in psychological measurement. But what happens when a tool doesn't measure what it's supposed to measure? Validity is the extent to which a measurement tool measures what it's supposed to measure. Remember your thermometer? It's measuring the room temperature, not your body temperature. Since it's supposed to be measuring your body temperature, the thermometer is not valid. In the case of the thermometer, we can easily see why validity is important. Without it, we don't know what our body temperature is. But what about in the case of psychological measurement? For example, imagine that we want to measure how empathetic a person is. We write a survey to find out how much people understand and feel emotions for the plight of others. If our survey has a high validity, it does a good job of measuring empathy in people. If it has a medium level of validity, it might be measuring something else, like altruism or guilt-motivated behavior. While both of these might be linked to empathy, they're not empathy. And if our survey has low validity, it might be measuring something else entirely, like intelligence or extroversion. But even if it's measuring extroversion or intelligence instead of empathy, who cares? Why is validity important? If we think that we are measuring one thing, but we're actually measuring something else, then it won't give us the information we need. Just as your thermometer didn't tell you whether or not you have a fever, our survey won't tell us how much empathy people have, which is what we want to know. But why wouldn't every psychological measure have validity? After all, we are writing the survey. Why don't we just write it to measure empathy? That's easier said than done because empathy is a construct, or idea that cannot be directly observed. Think about it like this. You can't see or touch or taste empathy. You can observe behaviors that indicate empathy, but not empathy itself. For example, maybe you see someone giving $1 to a homeless man or helping an old woman cross the street. These behaviors hint that the person might have empathy. But empathy isn't like the color of someone's hair. You can't look at it and say, "Oh yes, I can see that so-and-so has blonde empathy today." Almost all psychological traits are constructs. Intelligence, depression, empathy, prejudice, resilience, these are all psychological traits, and none of them can be directly observed. Instead, psychologists have to look at the people's words and behaviors and draw inferences about how those words and behaviors might relate to the underlying construct. But what if what you think is related to an underlying construct really isn't? For example, what if the person we saw giving the homeless guy $1 is helping because he wants to impress his date, not because he feels empathy? What if the person helping the old woman across the street is only doing it to clear the crosswalk so she can drive through it? Because we are always making inferences, and those inferences can be wrong, some measurement tools end up with low validity. There are several major types of validity. Number 1, face validity is when a tool subjectively appears to measure a construct. For example, if we give a survey to people to test how empathetic they are, we might look at the survey and say, "Yeah, this looks like it measures empathy." Face validity is not a good way to know if a measure is actually valid or not. It involves people's opinions, and opinions can be wrong. Number 2, construct validity is the extent to which a tool measures a construct. For example, if our survey actually measured empathy, it would have a high construct validity because it is actually measuring the construct of empathy. However, construct validity is hard to prove. As we've seen, many things can look like empathy, so construct validity isn't always easy to demonstrate. Number 3, content validity is the extent to which the individual items on a test are relevant to the content area that it is testing. If our survey had a question about whether a person liked spaghetti or not, it wouldn't have a high content validity because liking spaghetti has nothing to do with empathy. Likewise, you wouldn't put a spelling question on a math test. That just isn't relevant. Notice that a tool can have high content validity and low construct validity. Our survey might ask questions that are all relevant to empathy and therefore have a high content validity. But if it is measuring something other than empathy, like guilt-motivated behavior, its construct validity is low. Number 4. Predictive validity is when a tool can predict certain behaviors. For example, people who score high on our empathy survey might be more likely to volunteer regularly than people who score low on the survey. We can predict what they will do based on their responses to the survey. Validity is the extent to which a measurement tool measures what it is supposed to measure. Psychologists need high validity on the assessments they use so that they know they are studying what they are trying to study. However, it is difficult to have high validity because most psychological traits are constructs or abstract ideas that are not observable. There are 4 main types of validity. Face validity is the extent to which a tool appears to measure what it is supposed to measure. Construct validity is the extent to which a tool measures an underlying construct. Content validity is the extent to which items are relevant to the content being measured. Predictive validity is the extent to which responses on a measure can predict future behavior.
Okay, so I think that covers it pretty well, right? Concurrent, postdictive, predictive, criterion, internal, external, lots of forms of validity, very, very important to establish for all these measures that we have out there. And all of them essentially rely on the correlation coefficient to determine whether we have reliability, validity, or the lack thereof. What else can we do with correlations? So in the example we talked about, we looked at the way in which number of absences correlated with mean exam grade. But you guys know the grade book. You've seen it in Canvas. You haven't seen my side of it, but you've seen all your grades, which means I could also use other data that might predict your exam grade. So what else might predict exam grades? Honestly, percentage of homework assignments completed. Right? That certainly should be related to exam grades. If you're not doing any of your homeworks, you're probably not going to have a reasonably high grade. They should be positively correlated. And in fact, the information I get from your percentage of homework assignments completed might be different from the information I get about absences. Right? It's not necessarily telling me the exact same thing about you. They might be capturing different elements of your personality that are both related to the mean exam grade in slightly different ways. Part of it's probably the same way, right? Both might reflect some lackadaisical approach to the course. But then maybe the homework assignments were also, you got really confused on some of them and you're shy and you didn't ask any questions. And the absences were you also got really sick a couple of times and you missed material because of that. Those are separate ways in which those things can contribute, as well as an overlapping way. The method of partial correlation uses the correlation between two variables and looks at it through the lens of a third variable, if you will. So what it does mathematically is it finds the individual correlations between all of these. And then it does sort of like the way this Venn diagram represents, it tries to remove that unique influence of the third variable. So in this case, I said that percentage of homework assignments completed also would contribute to exam grade. We would see that represented by the sections labeled B and C. B overlaps with absences. So we want to see just how much absences relates to exam grade. We want to see how much that A and B portion is while removing C, while removing that extra influence, right? Partial correlation does just that. It removes the influence of the third variable, basically by holding it constant, right? Setting it equal to a constant mathematically, and then seeing what the relationship looks like without that third variable there. Okay, so hopefully that makes a little bit of sense. Another example, right? Venn diagrams, they're wonderful. Let's figure out who this individual is, right? We have to remove the influence of one variable to see how the other two might be related together. So we've got all the people in the world that leave things behind. We've got all the people in the world that break into houses. And we have all the people in the world that eat your food. All right, let's work our way through it. Who breaks into houses and leaves things behind? Yeah, awful burglars, right? They broke in and then they forgot to steal shit. How about who breaks into houses and eats your food? A stoned burglar, right? Broke in, meant to steal your jewelry, found your nachos, ended up eating those instead. How about who eats your food and leaves things behind? Roommates. Absolutely, roommates. Right? Sometimes those roommates are family, sometimes those roommates are friends, sometimes they're in a third category altogether, but all of them eat your food and tend to leave things behind. So now that we have these individual relationships, what would that total relationship imply about who leaves things behind, breaks into houses, and eats your food? Santa Claus, of course. All right. Really, the last thing I want to point out to you guys is a branch of statistics. Okay, so you're probably looking at this right now. Some of you going, statistics is really easy. Class is going to be a breeze. I just have to follow through with the math and learn the new methods and techniques of what I'm doing, and basically apply the recipe. Others of you might be saying, "Oh, this sucks. I don't ever want to do this again." Well, admittedly, you don't have to go into statistics to make a lot of money with your knowledge of statistics, right? And so there's a branch of statistics called psychometrics. Oftentimes, in fact, resides in psych departments in graduate schools. Psychometrics is basically the branch of stats that looks at the development of psychological instruments, tests and measurements, right? Basically for the analysis of behavior. Now, we have big data all around us right now. Our Google, my phone over here that's vibrating every now and again, is probably taking in all kinds of data about where I am, what things I've looked at today on the web, what my email contents are, and it's trying to tailor particular advertisements to me. Now, how does it do that? Well, because psychometricians have learned how to look at that data, how to see where they're correlated, how time spent on a website is correlated with age, for example. And they can then guess with reasonable accuracy what your age is just based on how long you were on that website. Okay, that kind of interpretation, that kind of analysis is what belongs in psychometrics. Sometimes it can be physiological data, it could be animal data, it doesn't matter. Psychometrics is so badly needed that even back in 2006, and it's even more so now, the New York Times said that this was a critical shortage of these individuals. So if you find this interesting, if you find this doable, if you will, consider looking into this as a potential career path. All I wrote in on Indeed.com, and this was, I don't know, about a week or so ago, right? So it's, let's say late January 2021. I typed in data analyst into Indeed. Let's see, 17,969 jobs. That's almost 18,000 jobs available on Indeed.com related to data analyst. Okay? Psychometricians, statisticians are needed, and they're needed way more so than they were in the past. Okay? So consider it. Consider the money if money is important to you. Consider the value of a fun job if stats is fun for you. Consider both in the ideal. All right? So that's it. I'll get off my high horse about psychometrics, but we covered a lot in these 4 videos, right? Talked first about standardized scores. These Z-scores allows us to compare apples to oranges or to cockroaches. We talked about how easy it is to then look at the position of a Z-score in the normal distribution and then determine the percentile, because we have all that table that tells us where all those numbers sort of line up. We then talked about the Pearson correlation coefficient and how to use it, the basic characteristics of it, -1 to +1, the degree to which the extreme value being -1 or +1 represents the strength of that correlation as well, relationships to cause and effect or lack thereof, right? Illusory correlations. We even talked about measures of sort of effect size or proportion of variance accounted for, some outlier effects. We talked about restriction of range, and lastly, we sort of wrapped up here talking about reliability and validity, and my little plug for psychometrics. So that's it. That's correlation, guys. Like I said, super easy, right? This stuff's a breeze. Next video, we're going to take correlation, and now that we know how 2 variables are related, and we started drawing that line, we're going to figure out how to draw that line, because that line allows us to see the future. Cheers.